In episode 67 of Mobycast, Jon and Chris discuss using custom CloudWatch metrics to monitor disk space. Welcome to Mobycast, a weekly conversation about cloud-native development, AWS, and building distributed systems. Let's jump right in.
Welcome, Chris and Rich. It's another episode of Mobycast.
Hey guys, good to be back.
Hey, so Rich, I saw you yesterday. We saw each other in person at a client meeting. That was a treat.
Yeah, it was good. It was a fun conversation. Nice to get out of Denver.
Yep, and I got out of Eagle too. We got kind of met in the middle and got a free lunch out of it. Can't complain.
Yeah, definitely.
Free lunch by a beautiful flowing Colorado Creek. It was amazing. So, Chris, what have you been up to? I heard you had June gloom.
Well, now I'm just jealous. free lunch by the side of the creek in Colorado, yeah. Status,
that's how we do business here.
Hashtag jealous.
So, anything else other than June gloom going on in Seattle these days?
Well, school year's winding down, and this is a big one because my son is graduating high school. So tonight is the graduation ceremony.
Next year, you're getting a boat and going sailing, right?
Yeah. Well, this is like where the tip jar comes out for Mobycast, right? To help pay for college. Right.
Yeah, maybe
no boat. There's no sailboat. No.
We're playing with a new thing. What's it called?
Glow.
That's right. It's named after a Netflix series. And it's just like a thing where people that are into Mobycast can give us a few bucks, and I don't know. We'll play with it and see if we like it. We're not doing this for the money, obviously. We're doing it because we just like to talk so much, and we like to record ourselves talking. So let's talk about today. We're going to talk about disk space, which is a thing that just has a tendency to bite you when you're running production systems. It's a thing that's a finite resource, and you can run out of it. And when you run out of it, computers don't like it, and they will stop running your code, and then you'll be down. And sometimes it's really hard to recover from, or you don't even realize that's why you're down. It's just like anybody that's ever run production systems for more than, I think if you run it for more than 19 days, you'll probably have a disk outage. So yeah, we're going to talk about that in regards to how, cloud native development, particularly around AWS, because that's what we know, and just talk about what you can do to make sure you don't run out, and I was trying to think of a metaphor. Like, this is we're going to do a little bit of black belt level AWS conversation here. Like, this is what you don't learn in the 1 hour how to use Elastic Container Service talk that you go to at the conference. This is like when it gets real, but I don't like the metaphor black belt. So what's another one?
It's kind of like, it's like the trade secrets.
Yes.
Right. It's like it's like you hire the plumber, right? And what took you 4 hours to do takes them 3 minutes, right? Because they do this. They've done it. They've done the hard work. They've done it before. They know the ins and outs. And so hopefully that's what we can do here, is that we can save some folks a lot of trouble and hair pulling.
Right. You're making me laugh because I didn't hire a plumber recently, and it's a good thing the snake was 15 feet long. I only had 5 feet to spare. And it took me definitely 3 hours of just, wishing I would have called a plumber. So yeah, let's get us started. Let's talk about disk space and, just kick us off, Chris.
In a way, I mean, this is really weird to talk about this, right? Because it's like, here we are, like 2019, cloud has been around for a long time. We have like AI, ML, facial recognition, where all this stuff is in the news now. Like, just like technology, wow! Like, it's just leaps and bounds, right? It's amazing how fast things are advancing. And yet here we are, we're talking about how to monitor disk space. So in a way, I mean, it's kind of sad, but this does end up being kind of like just it's a very practical problem that folks have. And as you mentioned, like, the longer something, a host is up and running, the greater the likelihood, right, that it is going to have problems with disk space, right? And that's because, apps that we deploy and are running, they're consuming disk space as part of just their normal operation, right? So whether it be in the form of log files, which is definitely one of the more likely suspects for growing disk space usage, things like container images, bugs like you have code that's writing temporary files, and maybe it's doing image manipulations or it's creating PDF files and then just not cleaning up after itself, right? And that can lead to this. So it is something that we have to deal with when you're running production loads in the cloud, that you do run into this, right? Where you just, it's all of a sudden something's not working, and it's because there's just no more disk space available. And so how do we even get to that point?
Hey, I'm curious, Rich, you run production workloads for WordPress with WP Engine, and I'm just kind of curious whether this is ever an issue over there, or whether WP Engine kind of takes care of this side of the world and you've just never seen this problem in your wheelings and dealings with WordPress. Just curious.
Yeah, I mean, we have a limit. I forget, it's like 100 gigabyte limit or something like that on our server. So like we do sometimes get within 20% of that. And when you get within 20% of that, WP Engine doesn't allow you to like clone into another environment and stuff like that. And you need to free up resources or upgrade. So yeah, I mean, like,
so it could happen where you could go down if you weren't kind of cognizant, but they take care of the monitoring for you.
Well, the way that they handle it is they increase it for you, and then
interesting.
And then if it happens another month, they charge you. And I mean, I don't know how they actually do it now, but when I was like, I think I was like one of the first 100 customers, and back then they just kept like loading it up until they could have a conversation with you about it. But yeah, I think theoretically, yeah, if you go over, you're in trouble. And for me, that would be big trouble because we have 60 sites that are, on the same box. Most of them don't do much traffic, so it's only a few of them that would, be causing that problem. But sure.
Interesting. Okay, so right on. I was just curious because it's a managed service, and Rich is friends with the team over there, so he was very politic in his response, which I thought was good. But going back to AWS and sort of the Wild West of deploying whatever in the cloud, disk space comes up a lot. Yeah.
And so, and as we talked about in the past, I mean, we were very much into containerization, and we use ECS quite heavily for running our apps. And that has its own nuances with disk space requirements. And it's not just the applications that are using up disk space to do things like writing log files. It's also just the number. It's a function of the number of different types of services that you're running, right? Because each service, each task that you're running, that's backed by a Docker image, and those are cached on these hosts. They need to be there on each host that they're running on. And so as you grow and you have more services that you're deploying, your disk space requirements are going to be going up, right? So the likelihood that you run into this problem of running out of disk space becomes even more likely to happen. So very much, a very real world problem that you're going to run into in production. So maybe we can start off by just talking about, like, as far as like AWS goes, like the standard there for just monitoring stuff is CloudWatch, right? So that's Amazon's, that's AWS's metrics and monitoring platform. And out of the gate, when you do have an EC2 instance, you're going to get some standard CloudWatch metrics for free, right? This is the batteries included part of it. So you're going to get things like CPU utilization, disk throughput, network throughput, and status check. So those are the standard CloudWatch metrics that you get for free, so that when you spin up that EC2, those metrics are now going to be available to you, and you can do whatever you need to on them. You can monitor them.
Did you just say disk throughput?
Mm-hmm. And by that, I mean, this is basically the number of reads and write operations you're doing, as well as the bytes that are being transferred for read and write, right? So it's the traffic.
I'm sorry. I was developing a theory of maybe why disk utilization wasn't a standard metric, and you just crushed my theory. Because if they're doing disk throughput, they're obviously capable of knowing what disks are mounted and what they're doing. And I was just sort of thinking, well, it's a little heavier lifting to, you can have lots of disks attached to a machine, and maybe some of them are even network mounted or whatever, So since it's such a configurable part of a machine, what disks it's using, maybe they're like, let's not go into that muddy pool and let's let users deal with that. But if they're doing disk throughput, they're in the muddy pool. They're standing there deep in it already. Like, come on. You're going to tell me how many bytes are going through this thing? You're not going to give me a warning when DF like gets up to close to 100% on these things? Come on.
Kind of, but think of it. I mean, it's definitely at a higher level of abstraction. So it's you think of this as more at the device driver level, right? So and this plays into like the VM itself and the hypervisor.
But is it always? I mean, like if you type DF, you get a response that has to do with the drivers that are connected to disks and what's mounted. And like the way that the machine is, like, it's a trustworthy operation. DF is not going to tell you about a disk that's on another machine. It's not going to tell you about a disk that's not mounted. So like, God, I don't know. I'm just frankly, I'm disappointed with AWS right now.
Well, and like, I mean, this is like, again, the real world practicality of it's just, this is one of those things that's just, there is a technical reason for this. Because I guarantee you, more than anything, like AWS has heard this loud and clear many times.
Sure.
Right. But, and again, I think it is related to like where the virtualization is happening. And so that at the level that this stuff is at, like it doesn't see devices and it doesn't see mount points and stuff like that. And things are coming and going. But as that bubbles up through like this virtualization stack, at some point it knows like, hey, I'm going off and I'm talking to network, or I'm going off and talking to disk. And at that part, that's where it can capture metrics, right? So that's why it can see like it can track packets that are going back and forth, if you will. But the actual, what's underlying that, like the actual architecture underneath that, like it doesn't see at that level.
Right. It's sort of like if it was, I mean, let me just say something and then you can say, no, you're wrong. Like, if to get the answer, you basically have to run a user level program on the machine, then AWS isn't going to get you that answer because it wants to stay out of there, stay out of that user level stuff. And it only wants to be at sort of the hypervisor level. Mm-hmm.
And I mean, and that is true, right? So like it's not part of the OS. And so if it is, if it is data that's only available at the OS level, then that's not going to be something that it can do.
Okay. Right? All right. Mm-hmm. I mean, I get it. Like, and it makes sense, I guess, with EC2. It makes a little less sense with ECS because with ECS, they are running an agent. You have to let them run a program on the machine. Mm-hmm. So it makes less sense there, I would say.
Yeah, and we can. I mean, ECS gives you a bit more stuff out of the box for free.
Okay.
So we talked about disk space, right? This is one of the things you don't like. The standard metrics you're not going to get that. You'll get throughput, but not actual space. And then the other thing that's kind of like noticeably missing is memory, right? And so that's another one that you're not going to get without custom metrics. On the ECS side, the ECS agent will publish metrics about your memory utilization, because that's one of the constraints that you have when running your containers on these services, is saying like, hey, what's my memory limit? Like, how much memory can I use? What's the max you can use? And so then there's metrics there for saying like what your utilization, like how close are you to that limit type thing. So you can then do some tuning. So there is some additional stuff that you do get with these more services that are built on top of it, right? But ECS agents run at a different level than in EC2.
Right, and I guess it's making sense. It's the same thing as it was with disk usage. In order to know how much memory you're using, you have to be inside the operating system.
Yeah. So that's CloudWatch. CloudWatch has a very robust, architecture for having these metrics being captured, for retaining them, for visualizing them, for graphing them. It also has the ability to monitor these things and set alarms. So these are just core key things that we use all the time. And everything is built on top of this, like almost everything I think is, so many things in AWS are built on top of CloudWatch metrics and the associated alarms, right? Like auto scale groups, that's how they work, right? They're monitoring CPU utilization or some other metric and using that on deciding when to trigger alarm to scale type thing. So given that we've talked about like, okay, it's not part of the standard metrics, so now we got to start talking about custom metrics, because that's what's going to get us to where we need to be able to, because at the end, what we really want to know is we want to know like, hey, are we bumping up getting low on disk space? And if we are, sound the alarm so that we can go do something proactively before we do run out of disk space, right? So that's what we're trying to do here. So in order to do that, we need to create some custom CloudWatch metrics around disk space. And so we need a mechanism for doing that. And so if you go do a Google search or whatnot to go start doing some research into how do you do this, you will find that AWS has a kind of a recommended way of doing this. So they've put together a collection of Perl scripts for doing these various OS level metrics. So metrics around memory and disk space and whatnot. And you can find the pages that walk you through all the steps that are needed to basically, you have to manually install this stuff, right? So you first have to install Perl and its environment and all the dependencies that are required on that. Then you go and basically download the Perl script package. And then once you do that, then you can actually start using it. And perfectly viable way of doing it. For me, when I was doing this for our ECS clusters, to me that seemed really heavy-handed, and I didn't want to have to install Perl and these dependencies just for disk space metric, right? That's all I really wanted. And so
it's a little surprising that that's still the recommendation given what you're about to say. Go ahead and say what you're about to say.
Mm-hmm. And you alluded to this before, right? You want to see what disk space is, just run df. And that tells you, for each one of the mounts that you have, how much, it gives you all of the stuff that you need, right? Like total capacity, how much is available and how much is being used. And so this is what df tells you. And so it's literally like you only need like a single line of bash, right? You run df, you pipe it through tail to chop, basically get rid of the header columns because you don't need that, and then run it through awk to say, give me the fourth column because that's the disk available number. And so just with that one line of bash, you now have your free disk space, your available disk space.
We'll drop that line into the show notes too. I think that's a nice little gem right there. It's a well-written bash script command.
Yeah.
Hey, this is Rich. Please pardon this quick interruption. We recently passed an internal milestone of 50,000 listens, and I wanted to take a moment to thank you for the support. I was also hoping to encourage you to head over to iTunes and leave us a review and/or a rating. Positive feedback and constructive criticism are both incredibly important to us. So give us an idea of how we're doing, and we'll promise to keep publishing new episodes every week. Okay, let's dive back in.
Yeah, so instead of going through all the, the hurdles and the hoops of getting the stuff installed and putting, software on your space, on your instance that you really just don't need, instead, just keep it simple and do something like that. And it makes it very obvious what it's doing, right? It makes it easier for people to understand what's going on, as opposed to, all this other stuff of installing a bunch of packages and then this black box of scripts that are being downloaded.
Right. And it's also a little surprising to me because doesn't AWS Linux come with pre-installed scripting languages? Like, doesn't it already have, say, Python on the machine with no installation necessary?
Yeah, it depends on what AMI you're using, but yeah, there's a range. There's a range of stuff there, right? So
yeah, everything's going to at least have shell and probably bash.
Yeah, yeah. Unless you're Alpine, and then but you still have a shell, right?
Yeah,
so you can still do this stuff, and everything will have df.
Right. Yeah.
DF and awk are like tail, like this stuff's going to be there. So, so that's all we really need to do, right, to get our disk space metric. And so now we just need to create this custom metric and publish it to CloudWatch. And for that, we really just have to make some decisions on like how we're going to name it. We're going to name it, and in this case, it's pretty easy. Pick a name like available disk space, right? That's our metric name. Yep. And then we decide on what the dimensions are, right? And so the dimensions are kind of the way that you are specifying what's the level of granularity. Like, what is this being measured? At what level is this being measured, right? So we definitely want to do this at the instance level, right? Because this is definitely an instance value. And then we may, depending on your setup, you may want to have further groupings. So like for us, these EC2s are host inside ECS clusters. And so for us, it makes sense to set the dimensions to be this metric to be done at the instance level along with at the ECS cluster level, right? So this way I can say, if I'm looking at my metrics, I can say, I'm going to go look at all the metrics in the development cluster of ECS, or I want to go look at all the metrics I want to see the metrics in the staging cluster, the production cluster. And then within that, then I would see it for each one of the instances that are in that cluster. Now I can inspect those even further, right? So it's a way of grouping these dimensions on it. And it's just going to be kind of up to you what makes sense. So, and it may be, if you don't have clusters, it may just be per instance. You could do it per scale group or something like that. So just something for you to think about and make a decision on.
Sure, makes sense.
So that's really all we need to do for creating our custom metric and for getting that data and publishing it. And so the next part is like, okay, we want to have an alarm that tells us when we need to be aware of this, right? So
before you go on to alarms, I guess there is one thing that I don't quite understand. So we have this little line of bash that can run and get information out. Is that something that we tell CloudWatch to run, or is that something that's just running? Like, is there like a place where you go paste this? I guess that's kind of what I'm curious about. Or is there something that you set up in the computer, and if you dump the thing right into this place, CloudWatch knows how to find it?
Mm-hmm. Yeah, I mean, so to publish your metric to CloudWatch, you're basically it's an API call or a CLI call, and you're basically just saying, okay, I'm publishing, here's the name of the metric, here's the dimensions, and here's its value, right?
Okay.
So what that bash line gives us, it gives us a number, right? It's the free disk space, and we will follow that up. Now we can make our API call or our CLI call to CloudWatch to say, for the disk space available metric, for this instance ID, and for this ECS cluster, here's its value.
Okay, right? Yeah, and I see we were going to get to that later. So, no, but I didn't before. Now I get it. All right, so let's talk about alarms and then kind of come back and put it all together.
Right. Yeah. So alarms, some key components there. Got to figure out a good name for them. So name them in a way that's allows us to organize them and find them. We're going to specify what metric we want to monitor. And then we're also going to specify the dimensions again, like what's the level of granularity for monitoring on this. And we're going to define a conditional expression in this alarm. And that's going to be composed of like a threshold or a value and a comparison operator. So like this is going to be, if the available disk space is less than 5 gigabytes, then that's going to trigger the conditional, right? Or it could be if CPU utilization is greater than 80%, right? That's going to trigger the conditional. So that's a key part of the alarm. And then we're also going to specify an action, right? Like what should happen if this conditional evaluates to true. And so typically, we'll probably post to an SNS topic, and then from there, additional things can happen. So, for our particular case, for disk space, we're probably going to want to have like an email sent, or, we could have something, published to Slack or whatever like that. But like, just keeping it easy, we'll just say like, hey, this is going to trigger an email whenever the disk space, available free disk space is below, say, 5 gigabytes. And so there'll be an SNS topic we can create, and we can have whoever wants to subscribe to that can with their email address, so that when this alarm gets triggered, there's going to be this email that's sent to everyone on that, letting them know that, hey, this alarm has been triggered. Here's the value, and you should do something about this.
And CloudWatch really works. I have a quick story to tell you, Chris. I think it was 3 or 4 years ago, I was playing around with some AI stuff, and I decided I was going to try to make a data set based on Twitter. And I wanted to get tweets, but only during when the market was open, because tweets outside the market being open were irrelevant to what I was trying to calculate. Mm-hmm. And I created a CloudWatch event or a CloudWatch alarm that would go and look to see if the market was open, and then send me an email when it opened and send me another one when it closed. And, it would kick off other things, but like I would know that it was working. Mm-hmm. I still get those things every day.
Unsubscribe. Yeah.
Okay.
So, and actually, when you think about it's like from just an infrastructure standpoint, like this is pretty amazing, like engineering, like what they've done with CloudWatch, right? Like, and just metrics and the graphing and just the alarming, like, I mean, just being able to monitor all this stuff, right? And to trigger alarms and to be so reliable. I mean, like that is quite the engineering feat. So tip of the hat to you, AWS.
A little bit schizophrenic on how we feel about AWS during this episode.
Yeah. Well, you gotta, there's a little bit of carrot and a little bit of stick, right? So those are the kind of the key components of a CloudWatch alarm. And again, you can create these alarms via API calls, via CLI calls, SDKs. Like there's all this, just the normal way of being able to automate this stuff and do it. So to put this all together, again, we're running ECS clusters, and each one of those clusters is backed by a launch configuration and a scale group. And so what we really need to do is we want to do two things during our host initialization, right? So one is we want to schedule a cron job that's going to go periodically determine how much disk space we have, and then publish that to CloudWatch as a custom metric. So that's the one thing that we need to do. And the second thing is just to go create a brand new CloudWatch alarm for that particular instance's disk space metric that it's going to be publishing. And then we're going to have some, whatever the threshold may be. So we'll just call 5 gigabytes. So those are just the two things we have to do during host initialization. And after that, we're done. So we're going to use the user data script as a way of doing this. And so this is it's a bash script that you have that's going to be run during the process of EC2 spinning up that instance. This is where you get to run whatever kind of custom code you want that's run once whenever that instance initializes, and then we'll be on our way. So it's
the thing about that. I wonder. It made me wonder if there's another way, because I think of CloudWatch as the cron of the cloud, and CloudWatch itself can run things on a schedule. Mm-hmm. And it would be kind of neat if you could just say, hey, for anything that's in this kind of auto scale group or this ECS cluster, just reach in there and run this and then get the output. So that CloudWatch could be the cron instead of having to do any scripting at all. It'd be kind of neat.
Yeah. I mean, it gets a little bit more
There's probably some more heavy lifting around IAM roles and access to the machines and stuff like that kind of would suck, but it would be cool if you could do that.
Mm-hmm. And just, determining membership set and how you actually specify the different types of membership sets that there could be, whether it's an ASG or something else, or is it a load balancer? I mean, so I think it would end up just the how do you actually define that feels like it would be pretty challenging and complicated.
But maybe worth it though, right? Because if you have a lot of machines out there, one of the things that I feel that's true about cron is it's where things go and happen in the dark. Cron is not really letting you know what it's doing, and it's got a secret little log file that you have to go find and see when things broke. It's kind of a little pain in the butt.
Oh yeah, well, I mean, it's kind of like serverless in a way, right? I mean, have the same problem with Lambda. So especially scheduled lambdas. So scheduled lambdas are the cron of cloud. Right. So I totally agree. When you're dealing with cron jobs, it is a bit of it's much less visible, right? It really is kind of like invisible code. And
here's another good reason to have a CloudWatch event. Go run the thing and then get the information back. So the CloudWatch event reaches in the machine and says, do this. And then the thing comes back and says, here's my result. The reason is if cron stops working for whatever reason, maybe it's out of disk space, so it can't do the thing that it's supposed to do. And it's not going to tell anybody. It's just going to be a lack of information. And with any kind of alerting or alarms or monitoring, it's the lack of thing that happens that's often the hardest thing to monitor. So at least if CloudWatch was reaching in and saying, run this little df command and give me the result, then if it wasn't able to do that, it might be hey, everybody, I wasn't able to do this thing I'm supposed to do all the time. Whereas if cron can't do it, it'll be I secretly am putting a little failure message into a secret file that nobody knows about.
Mm-hmm. Yeah. I mean, so, along those lines, I mean, another way of doing, so this is the way that, that we've set it up
Sure.
is relying on cron so everything's running on the instance itself, using cron to calculate this every 5 minutes, and then publish metrics to CloudWatch. Another way you totally could do this, right, is create a Lambda. So have the Lambda, schedule it so that it's running once every 5 minutes, have it go out. It can make the API calls to say what, you can configure it to what cluster you want to take a look at it. It can do the API calls to get the membership set of what instances are running inside that. It can then make API calls to your instances themselves. You can expose some hook there for it to report back, here's the metrics. And then your Lambda can then publish that to CloudWatch, right? So you can use Lambda as your cron type thing.
Right. Yeah, I guess into those trade-offs, like the development team is like, we were totally going to write that feature that lets users upload, this thing to their profile, but we spent the last 2 weeks building a disk-free utility.
Yeah, indeed. Yeah. So at the end of the day, it ends up being it's really that simple. So it's, we kind of started off saying like, hey, this is really kind of unfortunate that you have to do some lifting here to get this done. But I think, the important point is that it's really not that much, right? If you we talked about this, one-liner of bash using df to get the free space, do the CLI, just do an AWS CLI call for putting that metric to CloudWatch to publish it, using cron to do that every X number of minutes, every 5 minutes, and then also just wire up a new alarm based upon that metric. And now with those two small tweaks to our user data script, we're now going to get an alarm triggered whenever we go below that disk space amount. So
then the next thing to do is hook up another little script that goes and grabs you a little more disk space and sends you an email saying, hey, I just got you a little more disk space, just so you know.
Yeah, I mean, and that boils down like how you set up your EC2 instances, and is it the root? Is it the OS volume?
Right.
Is it EVM? All that kind of good stuff. So, but just getting the email notification is definitely a good step in the right direction.
For sure.
Yeah. I get maybe some practical things just to consider about this. So again, we treat our EC2s as cattle, not pets, right? So these things are coming and going. Instances are terminating all the time. New ones are spinning up. Just there's that churn. So we've kind of gives us this question of like, okay, well, all these metrics and alarms are per instance. And so they really are going to be short-lived, hopefully, right? They're definitely not going to be lasting for months and months and months. It's more on the order of days or weeks. And so, is there cleanup that's involved here? And so something that's kind of surprising, or maybe not surprising when you kind of think about it, but you cannot delete a CloudWatch metric. So once it's been published, you can't delete it. Just not an option. And also the default, the retention period now for CloudWatch metrics, it is 15 months. So it's 455 days. So we create an instance, we publish some metrics for it. The instance is terminated. Those metrics will be there for 15 months. So that's kind of not so great, given that we have this flux of things coming and going.
Yeah, don't put personal information in your CloudWatch metrics. That's what I'm hearing.
Oh yeah, absolutely. Right. I mean, because you can't scrub it.
Right.
It's there forever, or for 455 days.
Yes.
But with CloudWatch alarms, you can delete those. Right. And so I would say like the recommendation here is like, don't worry about the CloudWatch metrics for your terminated instances, because really you shouldn't be looking at those directly. We really only need the metrics to wire up the alarms. And so it's really the alarms that we care about. And so the only other piece here that we have to do is we just have to periodically reap any CloudWatch alarms that are out there for instances that no longer exist. And that should be the proper amount of cleanup for us. And so that can be, again, like create a Lambda job that runs, once every day or something like that, and just goes and queries for the instances that are active and looks at our CloudWatch. And when you name these things, like you should definitely have a pattern, right? So you can identify what they are. So like for me, for my CloudWatch alarms, I chose a naming scheme where it was like ECS cluster name dash metric name dash instance ID, right? And so like it's basically it's composed of 3 different variables, these names. So it makes it really easy for me to figure out like what the instance ID is that this alarm is associated with. And so to do that reaping becomes pretty straightforward.
Makes sense.
Yeah. So now no more excuses. Go monitor your disk space and get alarmed.
Excellent. That was super interesting. So, and I don't know, it's never stops being a problem until we just have auto disk expansion capabilities, never run out of space, just automatically make me more space. And then maybe this problem will eventually go away.
Indeed. Yeah. Of course, you'll pay for it.
Yes, you will. All right. Thanks so much, Chris. Thanks, Rich.
Yeah. Thanks, guys.
We'll talk to you next week.
All right. See ya.
Well, dear listener, you made it to the end. We appreciate your time and invite you to continue the conversation with us online. This episode, along with show notes and other valuable resources, is available at mobycast.fm/67. If you have any questions or additional insights, we encourage you to leave us a comment there. Thank you, and we'll see you again next week.